a reoccurring theme I always talk about. RF performance equals throughput. The more data you can get, the more you can divide your data among different RF channels, the better off you are. Band steering is a good example of that. There are typical devices out there. Some of your clients today are dual band. Now, we've actually had dual band clients for a while. What dual band means is a laptop or any other device that supports both 2.4 and 5 gigahertz. Now, that dual band part doesn't have to be 11N. There have been cards in the past that were 11A and 11G, both dual band respectively. So a dual band device has significant advantages. Being able to operate in the 5 gigahertz space gives you less noise, better throughput, cleaner channels, more channels to choose from. So anything you can do to make sure you operate in 5 gigahertz is good. Little side tip, if you ever are suggesting to a customer, or if you are the customer, buy dual band clients. It sets you up for the future the best. Now, when you have this dual band client, it won't do you a lot of good unless you have something called band steering on the access points. So on the normal access point, what will happen is that you will have an SSID, again we'll call it Corp, and that SSID will broadcast on both frequencies. Well, what happens is the normal client that goes through this, listening for beacons or sending out probe requests, they tend to always favor 2.4 gigahertz because the signal strengths are typically a little bit stronger. Client devices tend to like lots of signal, so they always kind of run home to 2.4 gigahertz when really they shouldn't do that. So what happens inside the Ruckus system? Again, this is called band steering. Notice we've talked about beam forming and beam steering a lot, but make sure you understand this is band steering. Band steering is the ability for, number one, the access point has to know that this is a dual band device. And it can do that. It will actually look for probe requests on the 5 gigahertz band, and if it sees the same MAC address, let's say this guy is AB-CD MAC address, and the access point will then remember, so it has to know who is dual band. So it has to know who is the dual band devices. Once it knows that, if this device ever wants to connect again or is ever going to roam, it can then steer them to the 5 gigahertz band. Now how they do it is basically, it will just give a little bit more opportunity. Maybe it will slow down 2.4 gigahertz probe responses. It basically just makes it a bit more enticing for the client to connect on 5 gigahertz. The end result is that the more devices you have on 5 gigahertz, the better off you are. It offsets the load on that 2.4, which we only have 3 channels on 2.4, where we have, depending on your regulatory domain, over a dozen channels in 5 gigahertz. So you always want to have band steering. Again, the great thing is you don't configure this. It's just on by default. And again, you can turn that off. So band steering gives you the ability, gives your system the capability to automatically direct any dual band client to the 5 gigahertz band. It's a simple thing that gives you extra performance, better channel planning, and just better capacity on your Wi-Fi network.